Last night after dinner, I went to the kitchen and got a glass of ice water. Right as I was about to take it back with me to the living room, I got a phone call. When that call ended, 30 minutes later, I returned to that glass of ice water to find that it no longer contained any ice. Now, either some little kitchen elves came and stole all my ice out of my glass, or the ice melted. As much as I'd like some kitchen elves, who knows, maybe they do dishes too, I know enough about heat and energy to know that the melting is the more likely option here. In fact, you do too, even if you don't realize it just yet. You might recall that there are three phases of matter called solid, liquid, and gas. You experience these phases all around you all the time. The ground you walk on, the water you drink, and the air you breathe, just to name a few examples. But what's really cool is that matter can change from one phase to another with the addition or subtraction of energy. This transfer of energy is also known as heat. Before we go any further, I need to make one thing really clear. When matter goes through a phase change, we call this a physical change because there is no change to the chemical composition of the matter. In other words, no bonds are broken, no molecules rearranged, nothing of that nature. This is really important because physical changes can usually be reversed, but chemical changes cannot. For example, you can refreeze your melted water back into ice, but you can't unburn a piece of wood. Make sense? Great. Let's go back to our glass of water to see how energy influences the different phases of matter. When in the solid phase of ice, our water has very little energy, but there is some there. Even though it doesn't look like it, the particles of that ice are vibrating ever so slightly. We can't see it because it's happening on a molecular scale, and they have so little energy that they only vibrate a tiny bit, but not enough to move around. So we are left with a solid piece of ice that doesn't do anything but just sit there and be ice. But if we add some energy to this ice cube, something awesome happens. It melts into liquid water. Melting is just the change from solid to liquid, and it occurs when we add energy, heat, to a solid. By adding energy to the ice, we add energy to the particles within that ice, and they can now move around a bit more. You can try this at home. Put an ice cube in a glass and try to move it around. The whole ice cube will just bump around the glass in one piece. But if you do this with liquid water, it will flow around the glass like any good liquid does. The particles of a liquid are not held together as tightly as the particles within a solid, so unlike a solid, a liquid will spread out to take the shape of its container up to the surface of the liquid. Now, what do you think will happen if we take back our energy that we added to get liquid water? That's right, we'll end up with solid ice again. This change from liquid to solid is called freezing, and you can think of it as the reverse of melting. In fact, while the melting and freezing points of substances are different from each other, they are the same for that one substance. What I mean by this is that while water and mercury melt at different temperatures, water both melts and freezes at 0 degrees Celsius, and mercury both melts and freezes at negative 39 degrees Celsius. Cool, huh? If instead of taking away energy from our liquid water, we add energy to it, we will end up with a gas. This change from liquid to gas is called evaporation, but you may be more familiar with the term boiling, which is how we describe the liquid during this phase change. By adding energy to the water, we are energizing those water particles, and they can now move around even more than in their liquid phase. So much so, in fact, that they spread out to take the shape of the entire container. That container might be a jar, a kitchen, or the entire atmosphere. You can try this at home by simply boiling a pot of water on the stove. Once the water gets hot enough, it will start to bubble. Those bubbles are liquid water turning into gaseous water, also called water vapor, and they're trying to escape. And believe it or not, once the water reaches that boiling point, its temperature doesn't continue to increase no matter how much you crank up the heat below. Instead, the water just keeps turning from liquid to gas, evaporating into the air. Do you think we can remove heat from water vapor to get back our liquid water? You bet. This change from gas to liquid is called condensation, and you've seen this one before too. Just go sit outside on a hot summer day with a cold glass of lemonade, and pretty soon your glass will begin to sweat. This sweat is just water vapor in the air condensing on the outside of your glass as liquid water. The glass is colder than the surrounding air, so as the water in the air hits your cold glass, energy, or heat, is transferred away from it and it turns back into liquid water. And just like with freezing and melting, you can think of evaporation and condensation as reverse phase changes. That also means that the temperature at which this phase change occurs is the same on both sides for a given substance. In other words, the temperature at which water both evaporates and condenses is the same, 100 degrees Celsius. Just like the temperature at which mercury both evaporates and condenses is the same, a whopping 357 degrees Celsius. Matter exists in three different phases: solid, liquid, and gas. Because these are physical changes, the chemical properties of the matter is not altered, just its physical state. This means that we can go back and forth between phases, and we do this by adding or subtracting heat from the substance. Melting is when a solid changes to a liquid, like when ice melts into liquid water. Here we are adding energy and therefore energizing the particles of the solid. They move around more, and voila, so does the matter in its new liquid phase. The reverse of this is called freezing, and is when a liquid changes to a solid. In this case, we are removing heat, which slows down the particles and returns them to a more stoic state. But we can also add even more energy to a liquid, like when we boil water, which gives us a gas. This phase change is called evaporation. The reverse of this phase change is called condensation, and it occurs when a gas changes to a liquid. For this phase change, we remove energy from the substance, which slows the particles back down from its more energetic gaseous phase.